Hello, my name is Austin Hamilton, and today I'm going to be talking about AI code completion. First, I want to go through a little bit of what I'm going to say, give a brief roadmap, and then we'll move on. So first, I'm going to start with an introduction. We'll start with kind of a little bit of the history of AI and code completion, and then we'll move on to what is AI, and then we'll move on to how we model programming languages. And then we'll move on to how AI code completion works using the previous two sections. Then I'll move on to two popular tools for AI code completion. And then I'll end with some thoughts on how to use AI code completion, so some things to keep in mind, and then I'll end with a summary. So in order to talk about AI for code completion, we have to go back and talk about how AI was first used for completing anything. So in the 50s, Les Ernest, this man pictured up in the top right, he started doing research at Stanford to create this algorithm called SPELL. Now, SPELL was officially released in 1961. It was the first algorithm that completed when you were typing something. So it was able to look at 10,000 common words and then complete a search and find a list of possible matches, and then it would give you recommendations as to which word you're trying to type as you typed it. So you could run a command, and given a subset of what you had typed, it would look for what you're trying to type. And this inspired research for decades to come. It inspired the beginnings of AI, or more so, it was part of the AI inspiration from the beginning. And this moved throughout time until today, when we have AI code completion is almost synonymous with development. You have AI code completion in just about any IDE you use, and you have countless other tools to use, such as Copilot and Tabnine. So before moving on to AI for code completion, I think it's important to bring up what is AI as a field, because we're trying to use it to complete this code, but if we don't know what it is or how AI agents do what they do, it's pointless to try and figure out how AI code completion works. So what is AI? AI is making machines think or act like humans. So it's trying to get them to reason. It's trying to get them to behave like humans. Essentially, we're just trying to simulate human intelligence in a computer, whether that be a robot or a algorithm trying to find the shortest path to someplace or something like that. So the way these AI agents do this is by having internal models. Now, these internal models have functions, so it's an internal function that maps input to output, essentially. In the case of, say, a robot, it would have sensors or some kind of input from the external world, and then it would use an internal function to map that to behaviors it should go through to represent human intelligence. Now, in some cases, these models are updated continually, or they, from the beginning, are updated, and then they are set. And this is known as machine learning. So this is getting machines, allowing them to be able to learn from their mistakes, learn from others, learn from whatever stimulus they have. They take in a training data, and then they can apply that to some kind of other data. And typically, what these models are trying to do is move towards a goal state. So this goal state can be minimizing some kind of performance, or maximizing some kind of performance, or getting to a certain area, or completing something within constraints, something of that matter. So before we move on to AI for code completion, I want to digress and talk about how we model programming languages in general, because it's pretty important to how AI is able to predict what you're trying to do. So a programming language is typically described or represented by a context-free grammar. So a context-free grammar is similar to a grammar in some kind of natural language such as English, Spanish, German, something that people talk to each other. So we'll take English as an example. So in English, a grammar shows you how to build sentences. And so there are rules you have to follow when you are speaking, and this is how you communicate, is you follow this grammar. So in programming languages, a context-free grammar does almost exactly the same thing. It just shows you how to build statements instead of sentences. So these statements would be some variable plus another variable. Is that a correct statement in the programming language? So how they work is by dividing the programming language into two major subsets. There's syntax and there's semantics. So syntax is seeing if things fit correctly. So, for example, an int or an integer in C# is an int. So if you typed in INTE, that would be wrong syntactically. Now, semantics, on the other hand, are the meaning of a program. They display what the program should do, how it works. And then these grammars are used to build statements recursively, and this is how you get programs. So on the right is an example of an English context-free grammar. So at the top you have S, which is sentence, and then you have noun phrase, verb phrase, and etc. And then you go down until you have the dog ate the bone, and it builds a complete sentence. So now I'll talk about how AI code completion works. So the AI models that these AI code completion algorithms use are trained on large data sets. Now these data sets can range from a few thousand lines of code to enormous data sets of millions of lines of code. And what they try to do is find patterns in those codes. So if they see that every time this happens in code, a for loop is created right after, they pick up on that pattern so that they can give you that hint later when they're trying to run on your IDE, whatever you're running it on. So they're looking at syntax and semantics. Again, like in a context-free grammar, the syntax is trying to figure out, okay, how do these things fit together? And then the semantics is trying to parse the meaning of the program in completion. So typically, these AI code completion algorithms have a semantics engine. So this is similar to how Google does Google searches. Essentially, it receives an input and then it tries to parse intent. So it's trying to figure out what do you mean? What are you trying to do? And then it applies those patterns from the large data sets to speed up that process. So now I want to move into two popular code completion products. One is Copilot and one is Tabnine, and I'll get into some more details in the next couple of slides. Copilot is an AI completion solution that was developed by GitHub. So the developers at GitHub used OpenAI's Codex to create Copilot. Now, OpenAI's Codex is a model that converts natural language to some kind of code. And the Codex has a predefined data set that is already trained on. It is a fully shippable model in itself, and GitHub had trained it additionally on some public GitHub repositories. So they used thousands of GitHub repositories to train this model to make it more accurate, especially for a code that is going on GitHub. And some features of Copilot that make it feasible, appeasing to developers is that it integrates very well with IDEs, so Visual Studio, Visual Studio Code, even NeoVim. A lot of these editors readily integrate with Copilot, and it's very easy. And then a big selling point of Copilot is its price. So Copilot offers 3 tiers of payment plans. So the first is a free plan. This is free to verified students, teachers, and open source maintainers. And then it is $10 a month for individual use, and it is $20 a month for company use. And it is very important that a company buys the company use plan, and I'll get into why that is the case here in a little bit. So here's a demonstration of Copilot in action. So this is a screen recording from the GitHub website. And the first section, the function declaration, is a simulation of a person typing. And then what is highlighted is what Copilot would have suggested and given as a completion to the input it received at the beginning. So the second product I want to talk about is Tabnine. Tabnine was developed by the Tabnine company. And the difference between Tabnine and GitHub is that Tabnine uses proprietary AI models. These models, they have different ones for different languages. So for example, they have one for Python, for TypeScript, JavaScript, etc. And the selling point of Tabnine is that you can buy the model or a copy of the model, and it is your model. So this is really tailored towards businesses. So you can then, once you have the model, you can host it on a server, the cloud, however you want to host it. But you can train it on in-house code. So you can take either the GitHub repositories you have if they're private, or anything hosted on a server. You can train it on that, and it'll pick up your specific standards and practices, which is quite appealing to businesses because they don't have to be as aware of these coding standards, or maybe not as aware, but as it doesn't take as much work to develop these coding standards with Tabnine. And the interesting thing about Tabnine is if you host it on your server, it is a private instance of that AI model. So there's no sharing of your code back to Tabnine. It is all hosted on a server, and you don't have to worry about it sending your code to a offsite server or anything like that. So again, here's a little demonstration of Tabnine in action. This is a screen recording from tabnine.com. So as you can see, the user types in some comments, and then the Tabnine algorithm is able to decide how to fill in the code for that block of comments. So now that I've talked about AI code completion, I want to move on to how we should use it as a whole. So first and foremost, AI code completion is an excellent tool. It can increase productivity with less typing, less worry about sticking to the nuances of code. It can make code more readable. There are a multitude of productivity increases. And then another interesting thing about AI code completion is that you can learn how to code from AI code completion to an extent. So if you know the basis, you can learn the best practices and how to make your code readable and things like that. However, I should point out that it is a tool. It shouldn't be used as a crutch. It shouldn't be used as the only way you are coding, because an AI code completion suggestion is just that, a suggestion. You should have to check it for accuracy, check it to make sure Everything is with coding standards, make sure it runs correctly, all of that. And then another important thing to keep in mind is the security of AI models. So, given what I've talked about machine learning, AI models remember what they see. That's how they learn. So, if you are a business and you don't want your code to be regenerated by another business or an individual, it is very important that you either choose a non-open source um, version of AI code completion, or you, for example, I talked about in Copilot, they offer a business plan. Always go for the business plan if you're a business. And then another thing is on the opposite side of that, if you are a business and you have proprietary code generated into your code, that can be a problem too. So it's good to be careful with which code completion products you use and how you use them. And I wanted to bring up that this image on the left was generated by Bing's image creator. I thought that it was a fitting image to place into a presentation on AI code completion. So I want to wrap up with a summary about what I've talked about today. So I started with AI code completion. It's had a long history from 1961 to 2023. We started with a single program that could predict what kind of word you were trying to say. And now we have all of these models such as Copilot and Tab9, ChatGPT, etc., that can generate large patches of code for you given small inputs. And it does that by combining artificial intelligence and machine learning with the theory of programming languages. And in my opinion, artificial intelligence code completion is a wonderful tool. It increases productivity, it allows for learning, it makes your code cleaner, it overall believe it's a good thing. If, and based on this conditional, if it's not used as a crutch. So the code it does give should be checked for accuracy, the code it gives should be checked for performance in certain cases, and a big thing is to also make sure the security of your system is good. So make sure it's not spitting out personal information. Make sure you're using a model that won't give proprietary information to other people, or you will get proprietary information that you shouldn't have, and things like that. And as long as those two things are considered, I believe AI code completion is here to stay and will revolutionize the way we complete work as software engineers. Thank you for listening to my talk. I hope you found it informational and helpful. Here are the references I use. I suggest reading them if you are interested in AI code completion or the context-free grammars and programming languages or any of that stuff. These are good sources. So again, thank you. Have a good day.